In this video, I'm going to talk about the derivative of inverse trig functions, okay, inverse trigonometric functions. So you have seen the trig functions in your trig class, okay. So let me review what you saw there. So for y equals to sine x, the notation for inverse of sine is we call y equals to arc sine x, or y equals to sine and then there is a -1 exponent and then x. We call sine inverse x, okay. Similarly, for the y equals to cosine, the notation is y equals to arc cosine x or cosine inverse x. So the domain, the values of x here is -1 through 1 for sine inverse x, and the range is the value of y is -π½ to +π½ including those, okay. Similarly, for cosine x, the inverse is cosine inverse, and the domain, the value of x is -1 through 1, and the value of y will be 0 through pi including the boundaries, okay. And also for tangent x, the inverse, the notation is arc tangent x or tangent inverse x, okay. The domain is -infinity to infinity and the range is -π½ to π². Similarly, these are the definitions of the inverse functions you saw in the trig class, okay. On this class though, we'll try to find out the derivative of these inverse functions, okay. For simplicity or for convenience, I want to use -1 exponent for the inverse instead of arc, but you can write arc sine inverse, arc sine x, that's perfectly fine. So I want to find out the derivative of find the derivative of y equals to sine inverse x. That's what I want to find out, okay. So y equals to sine inverse x, I want to find out y prime. The derivative is basically you want to find out y prime or dy over dx. You want to find out that, right? So how do I do that is you start with y equals to sine inverse x, right? And then this can be written as, if you take sine on both sides, what do you get? You get sine y equals to sine and then sine inverse x. The sine and sine inverse will cancel out, right? So what you get is sine y equals to x. You see that? Now you want to find out the derivative, okay? So how do I find out the derivative here? Is differentiate on both sides will give you d sine y over dx equals to dx over dx. I'm finding the derivative with respect to x. You see that? There is y sine y, there is x. So they don't match, right? So we need to use the chain rule. So this implies, what is the derivative of sine y? Is cosine of y. But since they don't match, you need to write an extra y prime, right? Dx over dx is basically 1. So this implies y prime is how much? You divide both sides by cosine y. You see that? If you divide this by cosine of y, you cancel out and then divide this by cosine of y. So basically you get y prime equals to 1 over cosine of y. But the question here is, your question is given as y equals to sine inverse x. Y is defined explicitly in terms of x, but y prime I don't want to write using y, I want to write using x there, okay. So how do I do that is, if you remember that the trig ratio formula, what is the value of sine square y plus cosine of square y? It is always 1, right? If you solve this for cosine square y, what do you get? Subtract sine square y from both sides. Sine square y and then subtract sine square y, sine square y. What do you get? Cosine square y equals to 1 minus sine square y. So the cosine y will be plus minus root under, right? So let me write down that. So it will be cosine y will be, so basically cosine square y is 1 minus sine square y, right? So what will be the cosine y then? Cosine y will be plus and minus root under sine square y, right? Sorry, plus and minus root under 1 minus sine square y. You see that? So that will be 1 minus sine square y, plus minus and then 1 minus sine square y. But do I need to consider both plus and minus? Let's see whether cosine y is positive or negative, okay. we started with y equals to sine inverse x. When y equals to sine inverse x, the value of y is the range will lie between negative pi half and positive pi half. The value of y will be between negative pi half and positive pi half, right? That is negative pi half, that is positive pi half. So this is the range of the sine inverse x, or the value of y in y equals sine inverse x. Now look at that cosine. Cosine will be positive in these two regions, right? The cosine will be positive. So you don't have to consider both plus and minus. You will consider only the plus sign there, okay? So what I'm going to do next is, therefore, I am going to write y prime equals to 1 over cosine y. I am taking the plus 1 only. So you can write 1 minus sine square y. So that is the value of cosine y. So let me write down the in terms of x under the root 1 minus, what is the value of sine y? Sine y is x. So sine square y will be x square. Okay. This is the derivative of sine inverse x. If you do the exact same technique, you will get cosine inverse x. The derivative of cosine inverse x is negative 1 over root under 1 minus x square. They are the same, only the cosine has negative sign, okay? Negative 1 over under the root 1 minus x square. That's what you will get. You see that? Similarly, I want to do for tangent inverse x. Exactly the same technique. I start with y equals to tangent inverse x. This implies if you take tangent on both sides, you will get tangent y equals to tangent and then tangent inverse x. Okay, so that will be just x. Now I want to find out the derivative after that. If you find out the derivative, you will get d tangent y over dx, right, equals to dx over dx. You see that? What does that implies? See, what is the derivative of tangent? It is secant square, but there is y, there is x, so they don't match, meaning you need to multiply by y prime. So it will be secant square y times y prime equals to 1. Now I want to divide both sides by secant square y and then over secant square y. So what do you get? You get that will cancel out, right? So y prime equals to 1 over secant square y. And again, see, our question had x in the right side, so we want to get that x form. So what is the relationship between secant and tangent? Do you remember that? We know that secant square y minus tangent square y equals to 1. If you add tangent square y on both sides, plus tangent square y, that will cancel out. So you will get secant square y equals to 1 plus tangent square y. See that? So I can write this as 1 over 1 plus tangent square y, right? But what is the value of tangent y? That is x. So I can write the final answer for this as 1 plus x squared. This is the derivative of tangent inverse x. If you do exactly the same steps, then you will get the derivative of cotangent inverse x is negative 1 over 1 plus x squared. You see that?